Today's lesson is on similar polygons, and we're going to see how we can use our knowledge from the last lesson, ratio and proportion, to put that to work in showing that polygons are similar. Okay, so what does it mean for polygons to be similar? Two polygons are similar, and here's our symbol for similarity. It looks like the little very top part of the congruent symbol. It's called the tilde. Two polygons are similar if corresponding angles are congruent and the lengths of corresponding sides are proportional. All right, and I copied this little piece out of the book so that you can see if this little quadrilateral ABCD is similar to quadrilateral GHIJ, then I know by the definition that all the corresponding angles have to be congruent and all the corresponding sides have to be proportional. In other words, AB, here's AB over GH has to be the same fraction that is the fraction of all the other corresponding sides when you put them in a ratio. I'm not sure that sounded the best, but anyway, the ratios of the lengths of the corresponding sides all have to be the same. That means the corresponding sides are proportional. All right, the ratio of the corresponding linear measurements of two similar figures. So in other words, above, that would be AB over GH. The ratio of any of the corresponding sides is called the scale factor. The scale factor of the first figure to the second one typically. So the scale factor, for instance here, so for example, the scale factor here, and sometimes I'm going to abbreviate this, is, and I can pick it, since I already know that these two figures are similar, I can pick any pair of corresponding sides because all the ratios are going to be the same, right? So I'm just going to pick AB over XY, and that's going to be 15 over 6, and of course I always want to simplify that, so the scale factor of ABC to XYZ is going to be 5 halves, right? 3 goes into 15, 5 goes into 6 2 times. So the scale factor of ABC to XYZ is 5 to 2. Okay, let's look at these figures and decide whether they're similar. So the first thing we want to do is we got to make sure that all the corresponding angles are congruent. I can see that corresponding angles are congruent. So now I've got to check the ratios of all the corresponding sides and see if they're similar. So I'm going to do FJ, and it corresponds to KN. So if 12 over 9 equals 8 over 6 equals 16 over 12 equals 20 over 15, then they're similar. Then they are similar. So I just want to simplify each one of those. 12/9 would be 4/3. 8/6 would be 4/3. 16/12 would be 4/3. And 20/15 would be 4/3. So yes, all of those are equal. So these are similar. So I'm going to say JFGH is similar to NKLM. NKLM. And just like was the case when we were learning about congruence, the order does matter. I have to have the corresponding vertices in the same order when I write a similarity statement. Okay, how about this second one? Are these two figures, these two triangles, are they similar? Well, right off the bat, without even looking at the ratios of the sides, I'm going to say no, they are not. How do I know that? Because all corresponding angles are not congruent. If they were congruent, they would all be marked as congruent, and they're not. So I'm going to say no, those are not similar. Additionally, if it didn't occur to me to check the angles first, when I did the ratios of the corresponding sides, those fractions wouldn't be the same either, so it would fail the test again. Okay, let's do a couple of practice problems. We want to make a scale drawing of the Empire State Building using the scale 1 inch is 250 feet. And of course you'll have this kind of situation a lot using maps too. I don't know, maybe people don't even really use maps anymore. But anyway, so if the building is 1,250 feet tall, how tall should your scale be? So I'm going to draw myself a little sketch because, you know, that's what I do. So here's my scale. And here's the actual building over here. We know the actual building is, 1,250 feet tall. And this one is going to be X. That's what we don't know. So I'm just going to set up a proportion that looks like this. 1 inch is to 250 feet as X inches for our scale is to 1,250 feet for the real building. Okay, now typically when we want to solve a proportion, we want to have the same units all the way through, but in a case like this, it's not necessary because when I cross multiply and then divide, all those units are going to cancel out, and we know that we want our final units to be in inches. But if you don't believe me, you can go ahead and change everything to inches, and you'll see that in the end you get the same answer. All right, so I'm going to go ahead and cross multiply, and I'm just going to drop my units for now, if that's okay. I'll put them back in at the end. So I got 250 times x equals 1250. So when I divide 1250 by 250, I end up getting 5, right? 5. And we're looking for how tall should the scale drawing be. The scale drawing is in inches, so I know my scale drawing is, the height of my scale is 5 inches. 5 inches would correspond to 1,250 feet. Okay, so this would probably be a good time for you to stop here and you work this next problem. Come back and see how you did. Okay, here are 2 flags. The small one is 3 feet by 5 feet right there. The large one is 36 feet by whatever the length. That's what we're trying to find. So this is simple. They're all in feet. So we're just going to set up our proportion of using the ratios of the corresponding sides. So I know that right here is where I'm working. I did my work over here. I took up too much room drawing a lovely diagram. So I know that 3 is to 36 as 5 is to x. That's my proportion. Okay, like always, I want to be sure and simplify things when I can. Otherwise, I'm going to have these large numbers to work with. So 336 is 1/12, and then when I take my cross product, I end up with x is 60 feet. So this flag here is going to be 60 feet. Okay? All right, here's another theorem. Similar polygons perimeter theorem. If 2 polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding sides. All right, so basically the scale factor, all that's saying is the scale factor of the perimeters is the same as the scale factor of the corresponding sides. So if KLMN is similar to PQRS, then we know that the perimeter of KLMN divided by the perimeter of PQRS is the same as the scale factor. So I could write all the corresponding sides here, KL over PQ, which is the same as LM over QR, which is the same as MN over RS, and finally NK over SP. Scale factor, SP, not SR. Okay, So that's it for content. I think the rest of this lesson is some practice problems. So yeah, we got 3 practice problems left. I think perhaps I'll do one and then you'll do the rest of them. So here we go. Pentagon CDFGH is similar to that other one, JKLMN. What is the value of X? Okay, so CD is the corresponding side to JK and DF. So what I know is that CD over JK equals DF over KL. So now I'm just going to plug in what I know. CD is X, JK is 2, DF is 9, KL is 6. I could simplify 9, 6, but this one's so easy I don't really need to. I end up with 6x equals 18. Therefore, x has to be 3. X is 3, which means the scale factor, don't forget, that's the scale factor, 3 to 2. Okay, and now we want to find the perimeter of the large one. So I'm going to call that P1, P2. So I know that the scale factor or the ratio of the perimeters equals the scale factor, right? That's what that theorem up there just told me. So I know that P1 over P2 equals 3 over 2. I know what the P1 is. I know the P1, it's 20, so I'm going to plug that in. And I got P2 down here. That's what I don't know. So what have I got here? Wait a minute. Something's wrong here. I got something set up wrong. Just a second. Yeah, what I got wrong is the perimeter of the little one is 20. So that's where I went wrong. So, all right. P1 over P2 is the same as the scale factor. I don't know what P1 is. I do know what P2 is. So what I end up with is that 2 times P1 equals 60. Therefore, P1 is 30 units, whatever they are. That's how I use that theorem. So there are 2 more problems on the next page. I want you to work those and then come back and check your answers. Okay, so what we wanted to do here is to verify that these 2 triangles are similar, then write the similarity statement and find the ratio of their perimeters. Okay, well we know if they're similar by the theorem we just learned a minute ago that the ratio of their perimeters is going to be the same as the scale factor. Okay, so remember, first thing we need to do is we need to make sure that all the corresponding angles are congruent. Well, we can see we've got angle P and angle V congruent. We've got angle Q congruent to angle T. What we don't have is angle R congruent to angle S. But oh yeah, remember our favorite theorem? Our favorite theorem of all time, the third angles theorem? Well, that tells us those third angles are congruent. I'll go ahead and mark those. So we're good on angles. Now let's check the corresponding sides. Well, without having to turn these triangles so that they're in the same direction, how can we tell which sides are corresponding? Here's a great way to do that. We're going to take the longest side of PQRS, and we know that it's going to correspond to the longest side in the other triangle. Same with the medium side, same with the shorter side. So that's what I did. I set up my ratios here. PR is PR is the longest side, and VS is the longest side in the other one, and so forth. Then I did the medium sides and the short sides. I set up those ratios, and when I simplify those, they do all equal 3/2. So since all the corresponding sides are proportional, I know that my triangles are similar, and I wrote my similarity statement, and let's make sure I got that in order. PQR is similar to VTS. I believe that's correct. And then, like I said, I know that the ratio of the perimeters is the same as the scale factor, so that's going to be 3 over 2. If you don't believe it, find the ratio of each one of them. Find the perimeter of each triangle, set up a ratio, and see if it simplifies to 3/2, and it will. Okay, how about the last one here? They tell us that the parallelogram JKLM is similar to parallelogram PQRS. Okay, and I just called JKLM parallelogram 1. I called this one number 2. And it says find the value of x. So of course I'm going to set up a proportion with corresponding side ratios to do that. So let's see. I know that KL corresponds to OR. And so this would be KL right here. This would be OR here. So I know that 8 is to x as ML. The other side I know is to SR. And when I substituted the numbers for that's 20 over 15. So then I simplify 20/15ths, change that to 4/3. I don't want to have these big numbers. I don't want to have to multiply 8 times 15. So I could switch my means, the x and the 4, but I don't really need to because 4x is 24. That's a small enough number for me to solve and to find out that x equals 6. All right. So once I know that x equals 6, then I can figure out what the scale factor is. The scale factor, well, actually I could have, before I solved for x, I could have done 20 over 15, but I'm going to do 8 over x is 6, and if I divide 2 into both of those, I get 4/3. 20/15 would also be 4/3. So there's my scale factor, which I also know is the ratio of the perimeters. Okay, so now I take that ratio of perimeters, and I know that the perimeter of the first parallelogram is 56. So I plug that in right there. Then instead of multiplying 56 by 3, I'm going to switch my extremes this time because that's going to make my problem much easier. So when I do that, actually, I take it back. I didn't do that. I switched the 3 and the 56. It doesn't matter. You can switch either one of them. I switched the 3 and the 56 so that I have 4 over 56, and that simplifies to 1 over 14. That makes my cross product an easy task because now I just have x equals 3 times 14, which is 42. So that tells me the perimeter of that second little parallelogram there is 42. All right, keep making your flashcards, studying those, and we'll see you next time.